Welcome to my channel, and today we're looking at a cross product, which is also called a vector product. So we'll be in this video looking at very important definitions of the cross products and some good things that we need to know about the cross products, the properties, of course, the properties of the cross product and so on. But in the other videos, we'll be looking at examples and on how, also be looking at how to calculate the cross product, how to use a cross product to get area and volume of some solids here and there. So let's just go straight to the definition and then begin by defining the magnitude of the cross product. And just before that, we need to know how to denote the cross product. And we are saying that the cross product, which we also call the vector product of two vectors A and B, is denoted by A vector A cross vector B. So this is how we denote the cross product if you're given two vectors A and B. Now, how do you get the magnitude of this cross product? The magnitude of this cross product is given by this. And you know this vertical lines means magnitude. So the magnitude of the cross product is the product of the magnitude of vector A and the magnitude of vector B times sine theta, where theta is the angle between these two vectors. So if you have two vectors, let me say that is vector A and vector B, there's an angle between these two vectors. This angle I'm calling theta. And so what I'm saying is that we can get the magnitude of this cross product. And the magnitude of this cross product is what we are defining as the magnitude of A times the magnitude of B sine theta. So this is not the definition of the cross product, but it is the definition of the magnitude of the cross product. Now, what about the definition of the cross product? The definition of the cross product must have the direction of this cross product. And so we must add times a unit vector. So that means if I were to define cross product of A and B, would be defined as the magnitude of A times magnitude of B sine theta times a unit vector. This will now be giving us the direction. This will be giving us the direction of A cross B, because you remember that A cross B is a vector quantity. That means it must have magnitude and the direction. So its magnitude is this, and then this will be the direction. And yes, erase this. And that is why I've said here that to obtain a vector, we need to specify the direction of the vector product in such that it must be perpendicular to vector A and vector B. So the direction of A cross B, the direction of A cross B is perpendicular to both of the vectors. So it will be perpendicular to vector A, and it will also be perpendicular to vector B. That is the direction of A cross B. So I've said that, so if we let that direction be labeled as N with a hat, that is hat N, then the vector product or the cross product of A and B will be defined as vector A cross vector B, which is given by the magnitude of vector A times the magnitude of vector B sine theta times hat n, or n with a hat, where this n with a hat would be a unit vector perpendicular to these two vectors. So that's a unit vector. And we already went through and we saw how to get a unit vector, which is perpendicular. And of course, we'll be looking at other examples and how to do that in our other videos. So now what is very important here is that we now know how to define the magnitude of the cross product, and is here. And we also know how to define the cross product. And this is the definition of the cross product, that we should not confuse these two. And we must know that the cross product is a vector quantity, meaning that it has magnitude and a direction. So there are some three important points that I've highlighted here. The first important point is that the cross product is a vector quantity and not a scalar quantity. And you know what that means? That it has both magnitude and distance. No, magnitude and direction. And the other important point is that given two vectors A and B, if these two vectors are perpendicular, then it means that the cross product will be given by this. The cross product will be given by that. Because what we have is that the cross product A times B is given by the magnitude of A times the magnitude of B sine theta with the direction. But sine theta will be sine 90. What is sine 90? Sine 90 will be 1. And therefore we are left with the cross product of A and B will be the magnitude of A times the magnitude of B, of course with the direction. That direction. So this wants to tell us where the cross product is pointing. Now, that is if they are orthogonal. What about if they are equal? If we have two vectors which are equal, or vectors which are parallel to each other. Now, if they are equal or parallel to each other, then it means the angle between them is 0 degrees, or it could even be 180. But what would be sine 0? Sine 0 would be 0. And sine 80 is also 0, 180. Sine 180 is also 0. So that means that if we have A cross B being equal to the magnitude of A times the magnitude of B sine 0 with that direction, that unit vector, and then this part becomes 0. Sine 0 is 0. So the whole of the right-hand side becomes 0. This part becomes 0. So that is why you have that for two vectors which are equal or which are parallel, and then the cross product is 0. The cross product of those vectors is 0. And that's very important for us to note. And the other thing that I've noted here is that the direction of the cross product, and that one I had already mentioned, that the direction of the cross product will always be perpendicular to the plane of the two vectors. So what I mean is that supposing this is a plane, and we have vector A and we have vector B. So this is vector B and this is vector A. The direction of the cross product will be perpendicular to both of these two vectors. So this will be the direction of the two vectors. No, the direction of the cross product, A cross B. So you notice that the A cross B will be perpendicular to the plane, and is also perpendicular to both of these two vectors. And that's what I've said, that is, the cross product will be a vector perpendicular to both A and B. That's very important. For instance, if you are asked to find a vector that is perpendicular to both vector A and vector B, then it means you just need to get the cross product of A and B. And if you get a cross product of A and B, then what you have is the vector that is perpendicular to both A and B. And you can be asked to find a unit vector which is perpendicular to A and B. A unit vector, and we'll be looking at such examples.